So guys, what we're delving into next, because we've been talking about statements and writing if-then, conditional statements, inverse, converse, contrapositive, and the biconditional statements. Then we also talked a little bit about proving statements with truth tables. I didn't assign any homework problems over actually making truth tables and doing those, but essentially we were doing that as well as showing that things were true or false. Because if I can prove one counterexample, then I can say it's false. And what we're really building up to is doing proofs with geometry, or geometric proofs. So showing that vertical or linear pair, two angles that are a linear pair add together to be 180. Proving that and going through the proof of that. And doing these proofs and explaining our steps as we go. But we're not going to jump straight into them immediately. What we're going to do is go back to something that you have done before in Algebra 1. Solving linear equations. We've done that. We've done that this year because 5x plus 7 equals 21. Solve for the value of x. We've done that. You all know how to do that. So we're going to add the element of what we'll actually be using to solve proofs or do proofs. I can't talk. Geometry with explaining each step, why we can do it. Now these are listed on your note sheet and they are on the reference sheet. And we have these here, the addition property of equality. If A equals B, then A plus C is equal to B plus C. The addition property of equality says I can add the same thing to both sides, and the equation is still equal. So I can add 2 to both sides of the equation, and it doesn't change anything. The subtraction property of equality, if A plus B equals C, then A minus C is equal to B minus C. I can subtract the same thing from both sides. The multiplication property of equality, I can multiply the same thing on both sides, and it doesn't change the equation. Division property of equality, we can divide the same thing from both sides, and it doesn't change anything. And our substitution property of equality, if A is equal to B, then A can be substituted in for B. Like we did with a lot of the problems, we found the value of x and plugged it back in. We substituted it back in. So let's look at our first example of actually doing this here. So we look at this first one here. We're just giving the justifications. Now when we do this and actually solve it, there's a lot of the steps. The simplifying step, we won't include that justification because we're just going to do it. Because when we look at this problem here, the first thing that they did was distribute the 2. Because they did 2 times x is 2x and 2 times 3 is 6. Yes? So we got 2x plus 6 minus 5 is equal to 5x minus 4. Well, 6 minus 5 is 1. Well, what do? They simplified. So when we actually do these, I won't have you do, okay, well, we write it out, then simplify. No, we'll just do the steps and just say, what is the next one? So like this here. So from here to here, what did they do to both sides of the equation? They subtracted 2x from both sides. So the property that says that we can do this is our subtraction property of equality. Because the subtraction property of equality says we can subtract the same thing from both sides, and it doesn't change the equation. Well, then they simplify. Then they actually subtracted 2x. 2x minus 2x would give us 0. 5x minus 2x would give us our 3x. What did they do next? Minus 4. Well, the reason they can do that is our subtraction property of equality. And then the next step they did was to simplify. Divided. So that would be our what? Division what? property of, remember, equality. And I'll go on and tell you this last one is our symmetric property of equality. A lot. Symmetric property of equality, but we'll actually cover that here in a little bit. Because the symmetric property of equality just says A is equal to B and B is equal to A. We can flip both sides of the equation. We're used to doing that. X equals 2, 2 is equal to X. It works either way. Are there questions over this here? Okay. Yes. Any questions over this here? Yes, ma'am. Okay. Now, this here is just really going through the properties and naming them, but I don't want to focus too much on that. I want to actually get to the lesson. Let's actually look at this here. Now, this here is going to be a little bit easier than what you think it's going to be. All right. Yep. Now, we're not going to worry too much about the explanation. I'm not too worried about the explanation. We're going to talk about the equation and the justification. That's the main thing, guys, we're going to focus on here. Now, the first thing that we're going to do is, well, write the equation down. Yep, right there. Yeah, so on your paper it doesn't have that explanations written out. So our original equation is 3x plus 2 is equal to 23 minus 4x, yes? Yeah. Well, how do we know that's the equation? Well, they told us, yes? And the reason for it was given to us. Whenever we start a proof, any of them, we'll always start with the given information. We're always going to start with what's given. Now, we need to solve for the value of x. What's our first step in solving for the value of x? Because I can add 4x to both sides. We could have subtracted 3x. Either works. Hold on. Now, we would just keep motoring through solving normally. But here we need to what? Give our reason. Why can't I add 4x to both sides? What property says I can? Addition of equality, yes. Because the reason we're going back to this is get you in the habit of, if I'm doing a proof, I can't just solve it. I need to give the reasons why I can do each step. So here the first one is the addition property of equality. Exactly. Then what would we do? Minus 2 from both sides, which will tell us that. And what's our reasoning for being able to subtract 2 from both sides? and yes, and this would be the division property of yep, right there. So I know it's a lot to write down. Jump in on the next one. Because I have a feeling solving it's not bad. Really what we're doing is getting y'all used to the justification steps and getting used to seeing how do we justify each step with something we already know, so that when we go to something we don't, it's a little bit easier to see. Any questions on this here? Let's look at this one. 6x minus 11 equals negative 35. Well, here, it's kind of already written out for us, but if we were doing it on the homework, our first one would be given. Especially on the test, this should be some of the easiest points to get, because we always start with what is given. So we'll 6x minus 11 equals negative 35 is the given. Yes. And this is our definition. Yes. So what do we do next? Well, so we would divide both sides by 6. Yes. So guys, we do have to put division property of equality. And the reason for that is because there are other addition, subtraction, multiplication, and division properties. Because we can talk about equality here because we're talking about two things being equal. Yes? Well, we can also have the addition and subtraction properties of not equality, but congruency. So we can talk about subtracting lengths or just lines themselves or figures and talk about the figures themselves. So we do have congruency properties and we have equality properties. We won't really use addition, subtraction, multiplication, or division properties of congruency because really we're talking about numbers themselves. But we do have properties that deal with equality and congruency. So the symmetric property of equality and the symmetric property of congruency. We'll see symmetric, reflexive, and transitive later on. But are there any questions on this here? Do y'all feel pretty comfortable with this? Okay. Distributive property. Yes, I combined 4.11 and 4.12 into one. I did that last year and forgot that I did it, and it wasn't until I printed the notes off that I realized I wanted as one. So I had them staple the two note sheets together because it's very easy to do them both. Now, You're good. You can staple it right back easily.
We do not.
Yep. Now the next thing we're looking at is the distributive property. Well, distributive property is just using our parentheses, and we will multiply through. Need help? Okay. So this here is just right below it. Yep. Yeah, so these are written a little differently. So we're solving negative 5 times 7w plus 8 equals 30. We're going to solve this here. Now, if we're solving this, the first thing we need to do is what? Write down the problem. Well, apparently I'm going to give you everything. And this is the given. Now what can we do next? We can distribute, because it's already written down for y'all. Because we can say negative 5 times 7w. Well, negative 5 times 7 is w. Negative 5 times 8 is negative equals, yes. And this would be our distributive property. Now, this would not be the distributive property of equality, because if you notice with the addition, subtraction, multiplication, and division properties of equality, did it affect one side or both? Both, because we're either adding something to both sides, subtracting something from both sides, multiplying or dividing both sides by the same thing, yes? Did the multiplication of the negative 5 affect both sides? No, it's just affecting the one. So we'll just call it the distributive property. That's why it's just the distributive property. Now what can we do next? Since the 40 is negative, we would add it to both sides, because negative 40 plus 40 is 0, which tells us negative 35w is equal to, and this here is our addition of quality. Huh? Because it's only affecting the one side. Because the division property, or the addition property of equality that we just used, because we affected both the left and the got added. When we multiplied the negative 5, it did affect the 7w plus 8. It affected 30. So it's just the distributive property, since it's not affecting both sides. Because any of the ones with equality will not just affect the left, but also the right. It affects both. So that's why we talk about it being equality. It's keeping everything equal. Any other questions? What do we do next? Divide both sides by negative 35. And this gives us w is equal to negative 2. And this is our division property of equality. Bless you. Division property of equality. And that's it. We got z by, or w by itself, yes? Any other questions on this here? Do we feel good with this here? Do we need to see another example of one of these? Okay. Now these here are very small. It should be the page that has 4 on it. I printed these smaller mainly because really I could go back and just make this a single page. I should do this one problem. Because the reflexive property of equality states that A is equal to A. Oh, really? Well, yes. Or the line segment AB is equal to the line segment AB. Or the measure of angle A is equal to the measure of angle A. It is equal to itself. Is the reflexive property. The symmetric property states if A is equal to B, then B is equal to A. We can switch the order. Or if AB is equal to CD, then CD is equal to AB. Or if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. We can flip it. Transitive property. If A is equal to B and B is equal to C, then A is equal to C. If AB is equal to CD, and we know that CD is equal to EF, then AB is equal to EF. And that's the transitive property. Because, especially with the transitive property, if I can show that these two are the same and these two are the same, then I can know that AB is equal to EF. if the measure of angle 6 is equal to the measure of angle 7, then the measure of angle 7 is equal to the measure of angle 6. What property? Symmetric property of equality. Yeah, name the property of equality that the statement illustrates. This is symmetric property of equality.
Does that say RIC for the last slide? Symmetric.
Yep. The next one, 34 degrees is equal to 34 degrees. Reflective, reflexive, R-E, yep, reflexive. Reflexive property of now, again, these are on your reference sheet. So on the test, you will have these down so that you can look at them. The measure of angle 1 is equal to the measure of angle 2, and the measure of angle 2 is equal to the measure of angle 5. So the measure of angle 1 equals the measure of angle 5. Transitive property of transitive property of equality. Any questions on this here? Now this here, I'm going to walk y'all through this. This is what we're getting to eventually. These are going to be geometric proofs. Now, we won't do any of these here. Your homework will not consist of an actual proof yet. We're going to do those later. But if we look at this here, in the picture we see that 1 and 3 are congruent. Because of the arcs inside the angles, it tells me that the measure of angle 1 is equal to the measure of angle 2. Well, how do I know that? It is given. In any geometric proof, we're always going to start with the given information, what it's told us. And that's what it told us. Now, it tells us also you reflect a beam of light, of a spotlight off a mirror lying flat on the stage as shown. Determine whether the measure of dBA is equal to the measure of EBC. We're wanting to show that these two are congruent. That's what the proof is. So what's our last step going to be? That the measure of dBA is equal to the measure of EBC. That's what we're trying to prove. So the last one that we'll have is that. So hopefully, especially come test time, that's some easy points because we know we'll start with whatever is, and we're going to end with what we're trying to prove. Now, we're trying to prove that these do work. Now, what we can say is that the measure of angle dBA is equal to the measure of angle, so dBA is 2 and 3, yes? So I can say it's equal to the measure of angle 2 plus the measure of angle 3. Now this here, we can do that in a minute, is the definition, or is our angle addition postulate. So the angle addition postulate. I ran out of room. Now we can also say that the measure of angle EBC is equal to the measure of angle 1 plus the measure of angle 2. All right. Angle addition postulate. So from the first chapter where we talked about two angles add together to give me the whole is what we're referring back to, because 1 plus 2 will give me EBC. 2 and 3 will add together to give me DBA. Yes? Now the given information said that the measure of angle 1, gosh, it must be a Friday because that shouldn't be a 2, that should be a 3 because these are the two that are actually congruent. Sorry about that. So we said that 1 and 3 are the same because it showed it, yes? Now, my addition property of equality, well, they're probably going to want this. We could say that the measure of angle 2 is equal to the measure of angle 2. This is our reflexive property of equality because it's congruent to itself, yes? In a minute. We already said 1 is equal to 3, yes? So I could add 2 to both sides. Yes? Because this is our property of equality. What is 1 plus 2? Measure of angle 1 plus measure of angle 2 is? Three and 2 is? And we can consider this the transitive property of equality. But we'll go through and delve into this here, and it's really utilizing these properties to show that things are true and work out. Okay, but that is it for today.